Today we will see lead code problem number 49 and it's called group anagrams. And it's commonly asked in Google, Facebook, Amazon, and even Uber and other companies. So it's a very popular question, though not so tough. And its difficulty level on lead code is given medium. So let's see the problem. The problem is that you are given a vector of or an array of strings, and you have to group the anagrams together. Anagrams are different strings, different words, which are made up of same letters and same frequency of each letter. So in this example, EAT and TEA, if you see, EAT contains one E, one A, and one T. So if we had one more E, then we would count them separately. And if you see T, again it's made up of T, E, and A, exactly same three characters. But let's say this had EEAT and then TEA, then although only three characters are used, their frequency is not same. So these are anagrams, EAT and T. Similarly, ATE is also anagram. Similarly, NAT and TAN are anagrams. So you have to group them together. You have to return the original words in the original array. You don't have to return the sorted thing. And you have to group them. So these three are anagrams of each other. And similarly, these two and this. So the strategy that we can follow here is that, let's say you create a map. So you have a hash map of string as the key and vector of a string as the value. So this is value, this is key. So what will be key? So you see that what is common to all three? If we sort all of them, we will get A, E, T. So A is the smallest, then E, then T. So you see that all of these map to the same key. So the key here will be AET and the value will be this vector, which is ATE, EAT and TEA. Similarly, second key will be ANT, the sorted form of this, and its value will be vector containing this, and the third key will be ABT and the value will be BAT. Now how do we build this dictionary? So once we have this hash map, what we can do, we can iterate this map. So I will iterate first key, I will get this one. So the return type of this function is, you can clearly see it's a vector, it's a vector, it's a vector, and it's a vector of vectors. So its return type is vector of string. So we will iterate all the keys of this hash map and we will simply push whatever is the value stored. So when we push the first value, initially this vector was empty, it will be holding just this first vector. Then we move to the second key and push the second value, which is again a vector of strings, and so on. But how do we build this dictionary in the first place? So what we can do is we can start iterating the original input array that we have. And so in the first iteration, our iterator will be pointing to this EAT. So what we will do, we will sort this. So we will get AET and then insert this into the dictionary. So if it's already inserted, we will just push back to it. So remember, the value is a vector, so we can always push back to it. And the first time it will be empty. So it will push back ATE and it will hold one value. Next time we encounter TEA, again we will sort it, and for key AET, we will push T. So it will be ATE and then T, and the next time we reach here, we will again push back. So let's write the code for this. This is very simple. It may seem complicated, but it's not. So the return type is vector, vector of a string. So if its size is 0, we will create a hash map whose key is a string, which will be the sorted value of any string, and the value will be vector of strings. So the sorted value of all of these anagrams will be same and mapped to the same key, and we will just keep pushing whenever we find a string to it. So it will automatically be appended to whatever vector it was holding. So we need to sort it, but the sort function in C++ sorts the string in place. It does not return a string, so we need to make a copy of it. And we will sort the key. And the way to sort a string is to pass the two iterators, because this sort takes two iterators in a list, and here the string is itself a list of characters. Key dot begin, and the second is key dot end. We are sorting the entire string. So this will sort EAT into AET. So this key is now holding the value of AET. Now what we will do, if we write map key dot push back, if we write map key equal to this string, then it will always override. So next time we get T, it will override it. But instead of just adding a value, we are pushing to it because the value is a vector of strings. So we can always append in the end. So we will push back S, the original word. And that's it. We have created our map. So we are done till this point. This map is ready. Now the only thing we need to do is to iterate this map, and whatever is the value, just push to the result vector. Initially it's empty. After pushing the first vector, it will become this. After second key, inserting the second value, it will become this much. And finally, we will push this much. And once we are done with that, our code should be complete. P I am writing for pair because in the map, unordered map, it's a pair, key value pair. You can write some more meaningful names. So let's check our code. Undeclared str. So it works. Let's submit it. So it shows runtime is not that great. Let's try once again. Again, it's not good. Let's try using iterator if we get any change or not. It should not ideally change anything. I'm not doing a big change. So we see some improvement. I don't know if it's due to this or just a random improvement, but you can try with yourself. It's not that bad. It's still faster than 45% of the online submissions that were accepted in C++. And in terms of memory, it's quite good. So you can try to tune it further if you can bring this number to more than 80%. So it remains in that range.